Okay, this is a real short video on a process referred to as tracing a program. So what tracing a program is going through and pretending you are, in this case, the Python interpreter, quote, executing lines of code one by one, keeping track of values of variables, evaluating logical conditions, etc., just like the Python interpreter would, to find out how variable values are set and what output might be generated. There are a couple of reasons that you would want to consider tracing a program. One is because your program's not working, you have some type of logic error, you've looked at the code, you can't figure out why it's not working correctly, so you go through step by step pretending you are the interpreter and trying to find out where you have gone wrong, where have you performed an incorrect calculation or something like that, for example. Another reason would be to answer problems like I have here at the top left, which is here's some code. How would it behave, or what output would it generate? So what we're going to do is we're going to look at this code and go through line by line. So this first line of code deals with two variables that we need to keep track of. There's a variable a and there's a variable x, and in this case we set a equal to 1 and then we set x equal to 1. So we're keeping track of the values of the variables just like Python would do. The next line of code, we have a while loop. The condition of this while loop is a less than 4. So we ask the question, is 1 less than 4? And that is true. So the loop will execute. So we go down here, and this statement will set x equal to x times a. 1 times 1 is 1. So just to be clear here, x had the value of 1. It's going to get set to 1 because of that statement. And then here we increment, that is add 1 to the variable a, because that statement is equivalent to a equals a plus 1. So a is currently 1. 1 plus 1 is 2. So 2 now, or sorry, a still now has the value 2. We're at the end of the while loop. We go back to the top and we ask the question, is a or 2 less than 4? That is still true, so we execute the loop and we set x equal to x times a. Well, 1 times 2 is 2, and we set that value to x. Then we go down and we increment a again. A is currently 2, so 2 plus 1 equals 3. We're at the end of the loop, so we go back to the top and we ask the question, is 3 less than 4? That is true. So we go through the loop again, do another iteration. So x times a is 6. We set that value to x. We increment a. A goes from 3 to 4. And then we go back to the top of our loop and we ask the question, is 4 less than 4? Well, that is false. So we fall out of the loop and we come down to this print statement. So we have a formatted print. So the beginning of this prints out a space equals space, and then we have a formatted value that we're going to mark off down here at the bottom. So the first thing we do is we look at the field width, and the field width is 2, so we mark that out. And then it says within those two characters, as a decimal value, print the current value of a, which is 4, and that will be right justified in the file width. Immediately after that, we have a comma, so we can put our comma there. We have a space. We have x space equals space. And then we have another value we're going to output, so we'll start marking off where this value is going to go. We look at the field width, and the field width is 3. And within those three values, we're going to output a decimal value, whatever the current value of x is, which is 6. So we write justify that 6 in the field width. And then since our field width has a leading 0, we will put leading zeros on this value. So the output would be a space equals space space 4 comma space x space equal space 0 0 6. So what we've done there is traced a really simple segment of code, kept track of the variables, and then correctly outputted or figured out what the output of that print statement would be.